Okay, next one. This one is really tough. Okay, this is a super tough question. One of the question that is super tough. Okay, so let me try to use the screenshot again. Okay. This one is a bit twisted, the question. Okay, you see, I have a STM32. F103RB is the one we have been using. I want to monitor water pH level. Okay. Okay, this one I think you can imagine this one. Okay, this is a water tank. Okay, there's some water there. Okay, I have a pH sensor. Okay, now this pH sensor will output something that is 0 to 3.3 volt. Okay, and this corresponds to 5 to 8.3. Okay, the pH. This is the volt. This is the pH. Okay, this is a pH. Okay, and this voltage okay, is connected to a A to D converter, ADC. Okay, and the ADC produced the answer 2482. Okay, now you remember the previous question I showed you this one. Show you this one. 0 to 3.3 volt. Okay, analog in. Okay, this is the digital out. Okay, straight line. Okay, so 3.3 volt will convert to 4095. Okay, this one is 4095. This is 0. So the thing now is I have something that is producing 2482. Okay, I want to know what is the analog voltage that is produced here first. Okay, that's the first step. So I think I can maybe this question mark, I just call it x. Okay, x. So x over 3.3 times 4095, okay, is equal to, okay, this answer 2482. Okay, so you work out the x first. Okay, so your x you just okay, let me just remind you again. This one over this one, okay, multiply by this one, 4095 will give you 2482. Okay, so all you need to do is your x. Okay, you just manipulate the formula this way. 2482 divided by 4095 times 3.3. Okay, this is a partial answer now. It's not finished yet. Okay, so let me calculate the, okay, in the lab test, I mean the MST, you have your calculator, so you can just work out the answer. Okay, so it's actually 2. Okay, very close to 2. Okay, this answer is 2. Okay, 2.000 something. Okay, now the problem is you only know 2 is produced here, 2 volt. But what pH is this? Okay, so all you need to do, okay, you need to have another straight line curve. Okay, the question says the sensor is a linear response. Okay, I just show you what's the meaning. Okay, this one is a pH. Okay, the pH can go from 5 to 8.3. 5 to 8.3. Okay, some of you may notice that the range is actually 3.3. Okay, this one subtract this one, the range here is 3.3. Okay, so the voltage here, the corresponding voltage, okay, which is the analog in. Okay, this is the voltage here is also the analog in. Okay, okay, I just oops, my, okay, it's going to be like this. Yeah, my 3.3. Okay, this voltage is also my analog in. Okay, let me just say again. The pH here produces a voltage which become the analog in of the ADC. Okay, so the pH will produce a voltage which is also analog in. But just now we have already worked out. Analog in is 2. Okay, so I have 2 here. Okay, so the question now is if pH of 8.3 is converted to 3.3 volt, what is the pH? Okay, what is the Y here that produces 2, huh? Okay, so I think the calculation is simple. Okay, you can just put the typical formula for directly proportional, but just take note that it's starting from 5. Okay, so what I want to highlight to you is 5 to 8.3. This range is 3.3. Okay, here to here is 3.3. This one happen to be 3.3. Okay, so if here go to here is 2. This is 2. Okay, this one is 3.3. From 0 until the maximum is 3.3. This is 2. Okay, this one is also 3.3. Oops, let me write 3.3. Oops, my pen. Okay, 3.3. Okay, 3.3. So if you imagine you go to the right by 2. Okay, this one you go to the right by 2. Okay, so I'm sure you can see 5 plus 2, this y is actually equal to 7. Okay, this is how you see the answer. This one is 3.3. Okay, this one also 3.3. This one go up by 2. This one should go to the right by 2. Okay, so 5 go to the right by 2, so it's actually 7. The pH is 7. Okay, so the answer is A here. Okay, it's a bit, okay, they made it very nice. Okay, so that you can work out the answer easily. If I give you some other number, maybe you need to, okay, you have to use a similar triangle. Okay, so let me just clear this part. Okay, question 3.4. Sorry, 34. This one. Okay. Okay, this one is 12-bit ADC. Okay, 0 to 3.3 volt. I think this one is okay, it's a reverse of A to D conversion. Okay, so let's screenshot this one. Okay, so sorry, these questions are all on A to D. So you may find it a bit dry. Okay, all same question. Okay, but you have to survive the MST no matter what. Okay, so this one, okay, this is my output. This is my input. Okay, 0 to 3.3 volt. Okay, analog input. Okay, so this is my digital output, and it's a straight line. My pen. Okay, so this one will go to 4095. Okay, actually 2 to the power 12. Okay, subtract 1. Okay, so 4095. You don't need to know this one actually. Okay, for this question. Okay, they tell you that the ADC returns something here that is E8A. Okay, they want you to work out what is the input at the analog in. Okay, so again, okay, what you need to do, okay, this hexadecimal, okay, you can use your calculator, convert to decimal first. Okay, so let me do the conversion. Okay, my handphone happen to be able to do that. Okay, E8A, okay, is 3722. Okay, so this one is 3722. So let's say I call this one W. Okay, so W over 3.3 multiplied by 4095 is the same as the decimal number 3722. Okay, so your W can be worked out this way. This is manipulation times 3.3. Okay, then right away you get the answer. Okay, so let me just do calculation again. 3722 divided by 4095 times 3.3. Okay, you will get 29999. So do I have 3? 3 is the answer. Okay, so C is the answer.